actually kind of started going into what we're supposed to be doing today anyway. We're all ready.
All right, sounds good. Well, let's just go ahead and start. And this is running already. So, all right, in October 2008, 684 of 1,006 random selected college students reported they had been involved with an automobile accident within the last 5 years. Find the proportion of those who surveys who have been in the automobile accident in the last 5 years. So it's just 684 over the 1,006, right?
Yeah.
And that gives us calculator going here. And we round that to a percentage or no?
I just left it at 0.6799.
Okay. That's what I got as well. All right. Check requirement in the constructing the conflict interval for this. So it's N, where were they? N times P or whatever.
Yeah, NP is greater than or equal to 10. And then N times 1 minus P is greater than or equal to 10.
Yeah.
So we plug that in. We have N, which is 1,006, right?
Yeah.
And P, which is 0.6799.
So definitely greater to 10, that one is the first one.
Yeah.
And so is the second one. All right. Yes, they are.
So the requirements are met. Nice and easy. Hold up in here.
You're right. Margin of error. All this written down. So for the margin of error, we can use the 1.96 for the Z, right?
Yes, because that's what pertains to the 95%, correct?
Yeah.
So you have the equation?
Yeah, I do.
Okay.
Do you?
Yeah.
Okay. All right, I'm ready when you are. Just let me know on that one.
Okay, I got, hold on, let me scroll back up to it. Yeah, here we go. On that one, the margin of error is 0.0288. Where'd it go? Right? Where did I get it? Yes, at 0.0288.
Oh, okay, I got something different. So I'm just gonna ask, did you do the one, do you know, I didn't times that by 1.96. Just kidding, 1 second.
So you got 0.0147.
Oh, nope, I got something way different. Okay, so I did 1.96, the square root of, so times the square, oh, I didn't do the square root of that either.
Gotta love math. You leave one thing out. And...
messes up everything, come on. Okay. Okay, did you get 0.037?
No. All right, so what did you do?
So I did the 1.96 square root 0.6799 and then in parentheses 1 minus 0.6799 all over 1006.
Yes.
So I did 1 minus 0.6799. And that I got 0.3201, so then it's 6.6799 minus 0.3201, and that gives me 0.3598, and I divide that by 1006, right? And that gave me 0.0035765. And then I got the square root of that, which was 0.018911. I guess I could do that. And then I did that times the 1.96.
Yeah, something's not right. Hold on. 0.6. Let me do my math again. And I ended up with the right number. So let's just go over this step by step. Okay, so for the top part, you did the 0.6799 times 1 minus 0.6799. Or, yeah, right?
Yes.
Which gave you what?
The 1 minus 0.6799. Then times 0.6799, right? There we go. I think I was subtracting those two. That makes sense. So I got this time 0.21764.
There you go.
There we go. And then that is divided by the 1006, and that gives me 0.00021634, and then find the square root of that. Which is 0.01471.
Yeah, and then multiply that by 1.96.
I got 0.0288.
Yes. Hold on.
All right.
Okay.
That was C, right?
Yeah.
Okay, construct and interpret 95% confident interval with a proportion of those who have been involved with the automobile accident in the last 5 years.
So basically, do you understand what they're asking for here? Because I didn't at first, and then I had to look
Is it the
at it
number
again.
of participants? Well, no, we have that. Is it the, oh, what is it? The high and the low, the upper and the lower? Whatever.
Yeah, so you just take the point estimate or whatever, the P plus the margin of error minus the margin of error. That gives you the high and the low.
Okay. So the P is 0.6799. So wait, the margin of error though, isn't that the Z times P whatever? So this is just 0.6799 minus or plus the margin of error, right?
Yes.
Okay, that makes it a lot easier. All right, I got 0.6511 and 0.7087.
And 0.651, 0.7087. Yep.
Okay.
So, I mean, really, we're 95% confident the true population is between those two numbers, right?
Yes. Okay, how many college students should you survey if you want 95% confident with margin of error? So this is where we do the number one, which makes sense.
Yes.
Okay, this one I do have a question. Is this the one that since we don't have P, or we can use the one with P?
We did not use the one with P on this one. I did it both ways and looked at the answer and the one where we don't have it.
Okay.
And that I'm not 100% sure why, actually, because we do have a prior estimate. We have the estimate for P, right?
That's what I thought, but I wonder if in the question, I'm not really sure.
But this one says, it just uses the N equals Z divided by 2 times the margin of error all squared.
Yeah. All right, I got 4,268 point something, so 4,269, right?
Yep.
Right. This lesson seemed a little bit easier than previous lessons.
A little bit. It's just figuring out exactly what equation to use.
Yeah. All right, and then number 2, hypothesis test. Now you're interested in testing a claim. Over 60% of all the students been in a car accident within the last 5 years. Use the same level or the same, information as above and use a level of significance as 0.05. So state the null hypothesis. It would be P is equal to 0.60, right? And then the alternative is not?
P is greater.
P is greater. Okay, so where did you get that P is greater?
Well, it says we're interested in testing a claim that over 60%. So P would be greater than 60, right?
Oh, there we go. I did not see that. Please don't eat that puppy. Yeah, that makes sense.
My thinking. Hold on.
Yes, you're right.
And that's also what they've got for the answer. So.
Yeah. I did not see the over. All right, compute the test statistics. Is this just the Z thing again? So we have, because we need to find what the.
Yeah, it's the Z equals.
It's the value. So I just wrote this down. The value over the mean. So P the P with the little asterisk minus the new P. So the mean.
Yes. Yes.
Okay.
It's basically what we put down for in our individual one, the formula for number 5, the test statistic for hypothesis test.
Okay.
That's what we're doing here. It smells like cookies in my house. It's making me hungry.
Hey, stop it, Tess. No. Hey, Brady.
Yeah.
Do you mind? She has a sticky note stuck to her foot that I dropped, and she keeps eating it. Stop it. But it's stuck to her foot. Do you mind getting that so she quits eating it? That would be great. Thank you.
Okay. Oh, it's hard to get out from that many covers. Yeah, that. Thank you. Yes. Here's your sticky note back.
Thank you. Yeah, I was like, hey, and so she stopped and looked at me, and she went to walk away from it. And she couldn't get on loud. No.
Okay, let's go, Jim. Ready?
No, I'm still doing this.
You want to call? You want to call?
Yes.
You could just say, but.
No, I've got this, and then we have to take a test after this, so it's going to be wrong, just so you know.
My pencil.
Or later.
15. Pen of 5. You good buckets?
Yes.
Oh, yeah, I need to go.
Okay. We got 5.173.
Yep.
Says determine the p-value based on test statistics. So this one we need to open up the probability applet, huh?
Yes.
Hey, Bree, there's a clean bowl in the dishwasher.
Yes, I'll do that.
There we go. Okay.
Maybe okay.
So we only highlight the top, right? Because we want it greater than.
Yeah, just one side.
So I got 1.1518E7.
Yeah, that's what it is. Issues with mine. It's not letting me highlight just one little part, so I just took and divided by 2 what it gave me,
Okay.
which is the same thing, or gives the same answer anyway. Ah, I was giving me excuse.
And since it's greater than 0.05, we reject the null, right?
Yeah.
Yeah. then the conclusion is we have sufficient evidence to say that over 60%, right? Or that it's greater than 60.
Yeah, sufficient evidence to conclude that over 60% or greater than 60%. All right.
Okay, let's take the test then.
There we go. Open up, start. Here we go. True and true.
And 3's A, right? Because that's the true population proportion. Because the regular P is the mean of the true population, right?
For questions 4 and 5, suppose n equals 100, p equals 0.25, and n equals 0.10. The requirements for constructing a confidence interval satisfied. You need
So it'll be 100 times 0.25.
yeah, so we should have it all, right?
Yeah, we do.
Okay.
And the first one's satisfied.
The requirements for conducting a hypothesis test is the z equals whatever, right? That's
Huh?
well, if we need to do a hypothesis test, we have all the information for that too, right? Yes.
What are the requirements for the hypothesis test again?
I believe they're just asking if we have enough information there to do it, and we do, because we've got both the types of P's and the N and the sample size, because it's the P with the ash whatever minus P divided by the square root of P times 1 minus P over N. So we have.
I know, but they're asking, are the requirements satisfied? So for number 4, we had to do the N times P is that greater than 10. And then the N
That's right.
minus P, that is greater than 10. But I don't remember. So yeah, the requirement for the hypothesis testing involving one proportion are the same. So, okay, so 1 is the N times the P with the asterisk, and that's the confidence interval one. So 5 is for sure true. I just did that one. Now I'll do the other one. And it's 10 or greater, right?
Yeah, I believe so.
Yeah. So yes, both of those are true. The requirements are met.
All right, a study of first-degree murder trials was conducted in another state. A random sample of 60 on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the point estimate of the proportion of first-degree murder defendants who are found guilty. You just take 45 divided by 60, right?
I'm double checking really quick.
Because that's x over n. Or,
Yeah, x over n will give us that, yes.
so yeah, it should be 45 divided by 60.
Yep.
Which I got 0.75.
Yep, that's what I got too.
3 decimals, got to add that 0 in there.
All right, create the 95 confidence interval.
So then we got to find the margin of error,
Mm-hmm.
which 95%, that's going to be 1.96 times the square root of p. So excuse me. So that's going to be the 0.750, right?
Yes, I believe so.
All over 60. Okay, so one. I'll check the square root of that. And then we'll so okay, so did you get an answer?
Give me like 3 more seconds. I got 0.1095 or 96.
Yes, I believe so. I already went through.
Okay, and then you add and subtract that, right, from 0.75.
Mm-hmm.
All right, and I got B.
Yeah.
Okay. All right. And it says if you increase the sample size, what do you expect to happen to the width of the confidence interval? It decreases, right?
I believe so. The larger the number.
Yeah, because I have reduced the margin of error by increasing the sample size.
Yes. So then the width decreases. That's what you said, right?
Yeah.
Yeah.
Okay, so find N.
Two requirements must be met. Suppose P equals 1/2. What is the smallest N can be and both requirements can still be met? So the requirements are, here we go. That's where,
So since we have P, we use the first one, right? The Z over M squared, and then P times, let's see, P times 1 minus P, right?
let's say that again.
So since we know P in this one, we have to use the upper one, right?
So the N equals Z, or
I think we use N equals the Z time, or the Z, which is 1.96, over M squared, and then P times 1 minus P, because we know P.
yes, I believe so.
Because we're using that specific P. Different one.
Oh, now, hold on. One second. Let me read the question. To conduct a hypothesis test for one portion, two requirements must be met. No, because the two requirements for the hypothesis test, it's going to be the NP is greater or less or equal to 10, and then N times 1 minus P is greater than or equal to 10, right? Is that what you said? Because I thought you said P times. So we got to figure out if we know. So we know what P is. We got to figure out what N is. That's what
Yeah.
you said, right?
And to
Okay.
find that,
So then we
remember
go.
there
That's
was
right. That's right. So up there.
Yeah, there's
Okay.
the 3 different ways to find it. One, you have P. One, you have the P asterisk thing.
Yeah.
And the other one, you don't have any P.
And the other one, you just have the Z divided by 2M squared.
And I figured
Cool.
since we have P, it would be the first one, right?
I believe so. Because we have the prior estimate for P. They're telling us P is 1/2. So 0.50. So what is the smallest N can be and both requirements still be met? Okay.
Hey, what do you get for the margin of error number?
I'm still working on that.
Okay.
But see, how do we find out the margin of error then? Because all we have at this point is the P, which is 1/2.
But we still have the number and the 1.96, right? So you can still use.
Well, that's where I'm confused. What number you said? What number do we have? What is So you're saying we have 1.96, that's for the 95% confidence, whatever. Yeah, right now I am a little confused.
Okay.
Because we don't, I mean, if we use, yeah, we don't have the margin of error.
That's what I'm thinking. We have to find it.
But how do we, Mike, and I see how we find it, but are we using 1.96 because it doesn't say anything about the
That's
95% confidence interval? So this is where I'm confused.
You're right. And you have to have the number to find the margin of error, and that's what we're trying to find. So we probably just do the Z, which is 1.96, over the 2 margin of error. We don't have the margin.
Well, yeah, we don't have the margin of error. We have the P, but yeah, we don't have, and again, it doesn't tell us that we're using 95% confidence interval.
I wonder if we're just supposed to use the information. It says 6 through 8. Darn it. Okay.
Yeah, I looked at that already too. See, I think if we got P, basically we just figure, we just use the 2, the NP is greater than or equal to, so we got to figure out what makes it at least 10. What makes both of those correct? If that makes sense.
So 20 times 0.5 will be equal to 10.
Yes. That's what I'm wondering if we're supposed to be doing. So if n equals 20, 20 times 0.5 is going to equal 10. So it's going to be greater than or equal to 10. And then if we plug that in.
So 20 is the smallest it can be.
What, does that work for the next one though?
No, because the next one is 1/10.
No. I mean the next part, because we got to make sure that it works in both problems.
Yes,
so we're
it
using
does.
20 times 1 minus. Well, does it? Well, yeah, because it should, right? It should be the same thing.
And then the next one's 100.
So, yeah, okay. So 20. Yeah, I think that's all there. I think we were trying to overthink this for a little bit.
Yeah.
For questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators, too much words, have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance. Okay. So let's look at that. That's, oops, cancel. Okay. The conditions for conducting a hypothesis test are satisfied. To conduct a hypothesis test, we need okay. Go back to this. So to be able to conduct a hypothesis test, we need the z-score both p's and whatever, right? Is that what they're asking? I'm confused.
No, I think they're just asking if the requirements, wait, are the conditions, just kidding, I read that wrong. The conditions for conducting a hypothesis test are satisfied. So to do a hypothesis test, it is,
My question, do they just want to know if we have the information to do it?
I think so, because it says the conditions, does that mean are satisfied? So I was wondering, I thought that that meant the requirements, kind of, those are satisfied. And they are. All of them are over 10. So.
Yeah. So are we saying true on that one then?
I did.
Okay. So what is that p? To find that out, we just take the x over the n, correct?
Yes.
Which is simple. 38 divided by 80. 0.475?
Yes.
Okay, so now we look for the z-score, or the statistic. And okay, so that's going to be the 0.475 minus 0.60, right? Because that was the original p.
Yes, that's what I have. Wait. So. Yes, I believe so.
That's what.
Yeah.
Um,
All divided by 80, right?
or not. Well, wouldn't that be? Because to find the z, it's the 2, 1 minus the other, and then isn't over the square root of. Yeah, it's over the square root, isn't it?
That's only, you're right, or the standard deviation.
Yeah, over the standard deviation.
It would be p times 1 minus p over n.
So 0.60 times 1 minus 0.60 all over 80. Because 80 was our number, right?
Yes.
So
Did you still get 80?
for what?
The square root of that. Oh, wait, I need to take the square root of 80. There we go.
But wait.
Just kidding. Never mind. Ignore what I was saying.
Yeah, I'm a little.
All right. I got negative 2.282.
You got negative 2.282? I got negative 22.822. Interesting. Okay, let's see here. Maybe I did something wrong. So the bottom Okay, so 0.475 minus 0.6 up top, right? And then
Yes.
0.6 times 1 minus 0.6 equals that divided by 80 equals, take the square root of that, and the answer.
Okay, wait, really quick. You got 0.24 divided by 80 at the bottom, right? Which is
Yes.
0.003, and then you take the square root of 0.003, right?
Yes, which gives me 0.054772255. And then I take that, or take negative 1.25, divide that by the answer, which is the 0.05 number, which gives me negative 22.82. 822 is what I got. I don't know where you got the one decimal over or where I got it over.
All right, so what did you get?
Negative 22.822 is my final answer, is what I got.
Okay, I'm still getting negative 2.28.
Okay, so let's.
Because you have negative.
I got negative 0.125 up top, right?
Yes.
Okay, and so let me just break this down.
Divided by 0.054.
47. Did you did you just go to the 3 over?
No, I had the 47 as well. 0.547.
Oh, you know what I'm doing? Haha. I think. Okay, hold on. I think I know what I did here. I do know what I did here. I put negative 1.25 instead of 0.125.
Okay.
Because that's how yeah. Okay, so we got negative 2.282.
Yes.
2.282.
And we're going to do the p-value. What's that? And it's just the bottom half, right? Not the top half.
Okay. Okay, so normal probability applet. What do we get? All right, so what did you get for that?
For the p-value, I got 0.011.
Yeah, that's 0.0112 is what I got.
Yeah.
0.011. What is the best decision for this test? It is smaller than 0.05, right? That's what we were going off of?
Yes.
So, I always get confused on it.
So we failed to reject the null hypothesis because there's insufficient evidence to conclude the water quality in the area has decreased. So I got A on 15 and B on 16.
And then B on 16. Looks, yeah, that sounds right. We ready to submit?
Yep.
'83. We missed number. I get there.
Oh, wait, that doesn't make sense to me. The symbol for the true population portion.
The P with the asterisk thing over it, I think, is a point estimator. If I'm looking at, because let's. Yeah, what is the formula? So, like number one in our individual says, what is the formula for the point estimate? And it's the P for a population proportion.
Okay, that's dumb. Darn it! And it was the opposite on 15 and 16. I thought that it for sure was the other.
So if it's lower than the 0.05, then we reject. If it's larger than it, we fail to reject. Because our hypothesis, or I guess in this,
oh, there we go. That's right. Yeah. So what confused me is in the answer sheet on the preparation, it's on the very last, it's what decision. I saw the P equals 1.15, which is larger, but it's actually 1.15 and then 10 to the 7th power. So it is 0.000. So it's smaller. So then it says we reject it. So then, darn it. That's dumb.
Still better than we did on our test.
Yeah. Come on. Sounds good. Well, and then really quick for I emailed you okay, where did it go? So the group project.
Yes.
Did you get the email?
I did. I actually just I'm opening it up on my computer. I looked at it on my phone the other night.
Okay. So I submitted that in the design the study.
Okay.
And I think it says final project overview. Only one, how I understand it, is only one person has to submit it, right?
That's what I thought. Also, let's see. Look at this again.
And I just alternated our names on the steps. So.
That's fine. That works. Yeah, after you've designated which members of your group will be in charge of each step above, ask your group leader to submit this document with the names filled in.
Okay.
Which is what you did.
Submitted.
So,
then I was thinking if we wanted to, let me pull it up really quick. But you had asked if we wanted to do like one big bag and a cup out of it, or a bunch of little bags. I said little bags just to make it seem more random. But if you wanted to do one big bag and do 10 cups out of a big bag, I think that's fine as well. Okay. Just a big bag of peanut M&Ms and original. And I was actually thinking, we bought 10 bags, so you could do 5 and I could do 5 of each.
Okay.
So that way we don't have like each 20 bags of M&Ms.
That'd be a whole heck of a lot of M&Ms.
Yeah. So that's kind of what I was thinking. That's why I said first we bought 10 bags of peanut M&Ms and 10 bags of original M&Ms. Then we opened each bag to assess how many of the M&Ms were each color. So if you wanted to do 5 of each, and I'll do 5 of each, that way it.
Yeah, I don't need 20 bags of M&Ms in my house.
Me neither. So, okay. So there's that. I figure that's as much as we need to do on it this week, right?
I think so. Look, design, because do we have anything? when is the next portion of it due? Oh, here we go. The Saturday of week 8 for the design this, wait. Because that's what,
So I submitted the design the study already.
yeah, okay, you already did that. Okay, that's,
And then we need to
so
get
the
it
next one is
approved.
collect the data after it's been approved. So,
Week-
okay, the assignment is due Saturday of week 10.
Yeah, and if
Gonna
we
let
can,
us know if it's approved, or is he gonna, I mean, how do we find out if it's been approved or not?
I think when she grades it, it should come back with teacher's notes or something like that. And then one other thing, week 10 is Thanksgiving weekend.
Oh, you gotta be kidding me.
If we want to, as soon as she approves it, maybe like next weekend do it and like collect the data. That way we don't have to worry about it Thanksgiving.
That would be a good idea. We could talk about it next week and whatnot.
Yeah. So I'll let you know when it still says that it needs to be graded and approved.
Yeah.
So I'll let you know when she does that.
Okay.
All right. Sounds good. I will see you next week then.
All righty. Have a good weekend.
Thanks. You too. Bye.
Bye.